Hi guys, hi everybody. So we are back on Orbiter, and this time in this tutorial we are going to take off and do a manual ascent to the orbit. So let me just put my taskbar here. So as I said, the ascent to the orbit, it's not going to be very hard tutorial. It's pretty easy to do it. The most important, or maybe the most hard part, is how do you ascend to the orbit manually, in that, in a sense that your orbit will be completely circular. And this is what you're trying to reach in that case. And during the ascent, I will explain how to do this, of course. So let's start our preparation for the orbit. Let's go to the upper panel and open and enable our lights. First, we will check our APU is on.
System reset.
Test master warning system is okay. All our mechanization and doors are closed and stowed. Um, so we will going to select this left MFD and put it on surface by clicking on select and surface. To the right side, you can see the map. We will put it here on orbit. So this is our orbital display. It will show how our orbit will is looks like in the real time. And in order, basically this is our orbit right now. In order to see our orbit like from the side view, we need to click projection. So when we click projection, we will have ship projection, and we will look at our orbital path from the side. Um, so basically there's a bunch of data right here, and the most important data is three parameters. Here is the PAR and APR and ECC. PAR stands for periapsis and APR stands for apoapsis. Basically this periapsis shows us the lowest point of our orbit, while apoapsis shows the highest point on our orbit, and ECC is the eccentricity of the orbit. So if the eccentricity of the orbit is 0, that means that the orbit is perfectly circular. And if the eccentricity is getting close to 1, that means the orbit is really prolonged, and eventually, if the eccentricity is too big, we will going to have the parabolic orbit, while that means we're going to do the slingshot around Earth and just go back to space. So now, what the point in with these two parameters right now is that they are counting their distance um, from the center of the Earth, and in order for us to get more sensible data, we want to count it from the Earth's surface. So in order to do that, we need to click, I think, reference. No, I will tell you exactly where we should. I think it's distance. Yeah. So if you click on DST, we'll have the periapsis is really close to the Earth's surface, and apoapsis is actually about 6.5 meters, which is basically our aircraft height over the ground right now. Okay. So we have set the interface. Now we're going to see if there's any other thing that we need to do. So the point with this aircraft is that when we're going to take off and the system computer will going to tell us that we reached takeoff speed, um, it still will take at least 200 kilometers per hour more in order to take off, which is not really realistic. So what I like to do during this takeoff is to use help from the hover engines. So we click on hover doors to open, and we will apply the hover engines. Other than that, I think mostly everything is ready, and we are ready for takeoff. So let's do it. In order to apply the hover engines, you can use the short key and click on the numbers button of 0 or del on the right side of the keyboard. So if you click on 0, we will apply the thrust of the hover engines and apply the thrust around 3/4 of the lever. And now we will apply the main engine around half of the lever. And we will start rolling. I will put the secondary HUD on
100 knots.
this position. 100 knots.
V1.
V1, rotate,
Wheels up.
positive rate, gear up.
Gear up.
So it's going to bring us about 20
Gear up and locked.
degrees above the horizon. We will shut down the hover engines and we will stow our hover doors. Now, right now, it doesn't matter which direction and heading we're going to take ourselves in order to get to the orbit, because we are not going to get to any space station around the orbit. If you want to reach some space stations, we need to time it correctly and fly to a proper heading. But for the sake of simulation, if we want to get to the International Space Station, we should fly the heading of 042 degrees, or if I'm not mistaken, 135 degrees, depending on where the station is sweeping right now and what time. So we're going to change it to 42 degrees right now, smoothly. And as we reach 42 degrees, we're going to apply full power and start ascending slowly in order not to get too much G's and too much pressure on the vehicle. And we're going to slowly ascend around 70 degrees above the horizon pitch.
Is it working well for you?
So we reached Mach 1, which is basically went over the sound barrier. We are already on the altitude of 10 kilometers, as you can see here, and speed of 360 meters per second. You can see here the static pressure already dropped around 8 kPa, which is around 7% of the atmospheric pressure that is on the ground. So we're almost close to vacuum right here. So now when we are close to 30 kilometers, we can start slowly put the nose a little bit lower. Now, as you can see, we have around 71% of fuel. And we can see that our speed vector, this circle with the plus sign inside of it, this is our speed vector. This is actually, sorry, this is like a velocity vector. This is actually where the aircraft is flying, opposing this bird, which shows where the nose of the aircraft is pointing. So we will try to hold a little bit more on the position of 65 degrees, and bit by bit we'll start to make this descending. Now we're already on 68 kilometers. There's almost no air. I should have done this before, but we need to put RCS mode on rotation and close the airflow control off. So as you can see, now we are using reactional control system in order to navigate in space. So now we should start getting our getting our nose lower. And Well, congratulations, we have reached space. Well, already on 105 kilometers above Earth, and we need to start getting our nose a little bit lower. We have reached velocity of 1.7 kilometers per second. Now, in order to reach orbital velocity around Earth, we need to have around 7.6 kilometers per second. So we have climbed enough altitude, and now we have to relay this potential to the horizontal speed because we need to reach the orbit. Now, by the way, the heading, if it's going to be around 6 degrees to each side, it's okay. It's not a big of a deviation that we can't be able to fix later if you are aligning yourself to um, orbital plane of the other body that you wanted to fly to, for example.
Well, that also clears up a bit of confusion from our part, and the plan that you just outlined is excellent, and you'll go for that.
Okay. So, because we flew and had the vector flight up, we are waiting for our velocity vector to go down and be close to the direction of our propulsion. We have around 38% of fuel. Now, it's important to understand that the less fuel you have, the more efficient is going to be the engine because it has to push less mass to gain velocity. You can see that our orbit is getting the shape that we want.
Upstream 1, check out part A. We're in step 2, looking for your go. Discovery Houston, for Wendy on your question, we do not need the serial numbers. We'll get them when you get back.
Our vector of flight is slightly to the right of the direction of 042, so we will going to take it a little bit to the left to do small correction. Not too much. So in order to make the orbit fully circular, we want to have the eccentricity of 1, and that PAA and APA parameters will be around the same values above the Earth. In order to do that, when we are going to cut off the engine at around 7.6 kilometers per second, we will have to make sure that our velocity vector is going to be exactly at the horizon on this line. So at the late stage of the burn, we need to get the nose position in that way so that the velocity vector will be exactly on the horizon. So now it's getting to the horizon, but it's still too early. We will want to raise our nose a little bit. And we will try to preserve it at that
is the one
place.
that we're concerned about.
Let's see our fuel. We have 13% of fuel. You can see to the right side our orbit is growing. In order to get to the orbit, we need to make sure that the PEA is going to be at least 100 kilometers above Earth. Otherwise, we will catch the atmosphere drag on the lower part of the orbit, which is the periapsis, and we will going to get back to Earth.
Warning. Main fuel low.
Okay, we have warning of low on fuel. We have like around 4%. I think we're going to get to the orbit anyways. Yeah, we can lower the nose down. PA. Okay, cut off. You can see we reached the PA of 268 kilometers and AP of 290. So it's pretty much close to circular orbit. Our eccentricity is only 0.0017, so we have a deviation of around 22 kilometers of altitude, which is fine, by the way. So we made it to almost perfectly circular orbit right now. We cut off our engine, and we have at around 0.8% of fuel, which is really not that much. So I wouldn't say that was like the most fuel efficient ascent that we have done, but it was just a tutorial to how to get to the orbit anyways. And if we do feel that we don't have enough fuel in our main tank, we just can use the crossfeed and just to bleed out some RCS fuel, pump it to the main fuel reservoir.
Information. APU running.
I think that 50% is going to be enough. 40%.
Crossfeed.
That's it. Okay, we're on the orbit now. We can. What we need to do is we have to deploy the radiator in order to make our coolant temperature drop. And in that sense, we can close the nav lights and the strobe lights. Just leave the beacon lights, and we can
System reset.
close the APU. And congratulations, we are in space, guys. Now we can put, instead of the surface MFD, we can put map. And we see that we are crossing, I think it's Nova Scotia right now, and going flight in the North Atlantic Sea, ocean. And what the last thing that you want to do is you want to put the heads-up display on orbital mode, because we are already on orbit. You can see the temperature display shows the temperature of external temperature of minus 165 degrees Celsius. Static pressure is 0, of course, because we are in space.
Houston on air to ground 1.
And that's it, guys. We are in space. You can enjoy the beautiful view while we're on the orbit.